For our do now today, we're going to simplify a variety of expressions here. Just a reminder, our rules for simplifying exponents, how we know when we're done. There's no exponents with number bases, no parentheses, no zero or negative exponents, and then I said no same bases, meaning there's no multiplication going on with the same bases or division with the same bases. So I don't have x squared over x to the third. I've reduced that to 1 over x, and so on. Okay, so let's go to our do now. We've got 1 over x to the negative second power. I can see the base of that negative 2 is x, so that's going to go up top. 1 times x squared, just x squared. 5a to the negative second power. In the parentheses, the whole base is 5a. Now watch as we put that into the denominator. We keep the parentheses, 5a squared. Ooh, not allowed to have parentheses when you're simplified, so I have to expand it. That's going to be 5a times 5a. Ooh, no multiplication with same bases. We have to simplify that. Is going to be 25a squared. Now we are fully simplified. Okay. Number 3, right? 3m squared times 4m squared. 3 times 4 is 12. 2m's being multiplied, and then another 5m's being multiplied. That's going to be 7m's being multiplied. 12m to the 7th. Number 4, we see our division. I want to remember that m has an exponent of 1. And that 5 goes into 5 once. 5 goes into 24 times. So that's going to be 4 in the numerator. Let's see, 1m on top, 3m's on the bottom. That means 1 can cancel, leaving 2 on the bottom. N to the 5th up top, n squared on the bottom. That means 2 of the n's can cancel with 2 of the n's on top, leaving 3 n's on top. Remember, when in doubt, expand it out. So we absolutely could have just expanded this all out. And then gone through and canceled everything by hand. And gotten to the same place. So it's your choice there. On page 11 in our booklet today, we're going to look at what we call power to a power. And that just means we have a number or variable with an exponent raised to another exponent. So we can see an example there where we have 3 squared, then to the 3rd power. Now we're going to start from the outside and work our way in as we expand to show the repeated multiplication. So I ask myself, what's the base of the exponent of 3? Well, it's grouped in parentheses, 3 squared. That means we have 3 squared times 3 squared times 3 squared. That's what that outside exponent of 3 shows us. But this can be expanded further. Each 3 squared is a 3 times 3. So let's expand that. 3 times 3 times 3 times 3 times 3 times 3. Okay. Number of repeated factors. So how many times is the 3 repeated? 6. So 3 to the 6th is 729. And now we're simplified. Okay. Our next one, we have 2y to the 3rd power. Let's just write in there that little exponent of 1 that we know the 2 has. Again, let's work from the outside in. Our outside exponent of 3, its base is 2y to the 3rd. So that means our first expansion, we're going to have 2y to the 3rd times 2y to the 3rd times 2y to the 3rd. Okay. Now we can separate those coefficients and expand the exponent as well, making it 2 times y times y times y times 2 times y times y times y times 2 times y times y times y. Now here I'm going to regroup using our commutative property. 2 times 2 times 2, and then y times 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 y. As we go and look at the number of repeated factors, let's make a little t-chart. We'll talk about repeated factors for 2 and repeated factors for y. We have 3 repeated factors of 2 and 9 repeated factors of y. So we think this in terms of repeated factors, that means this would be 2 to the 3rd, y to the 9th, which would simplify to 8y to the 9th. 8y to the 9th is simplified, but I want you to write down 2 to the 3rd y to the 9th also to help us with our connection we're going to make. Our last expression, our last example, we have g h to the 4th squared, right in that little exponent of 1 for g. Okay. Work from the outside. What's the base of the exponent of 2? Gh to the 4th. So that means we have gh to the 4th times gh to the 4th, which can then be expanded further. G times h times h times h times h times g times h times h times h times h. Okay. And then we can reorder. G times g times h 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 times h. And again, we'll make a t-chart for our repeated factors. G, we have 2 repeated factors, and h, we have 8, which means our simplified expression is going to be g squared h to the 8th. Now we want to go back at our examples, and probably the easiest place to see our example is looking at the first one, 3 squared to the 3rd power, right? And looking at our final answer, we have 3 to the 6th is 729. Well, how do we go from 3 squared to the 3rd to 3 to the 6th? To me, it looks like we kept the base and multiplied the exponents. Now let's test that for the other ones. Well, with y, 3 times 3 is 9. That works. Oh, yeah. And then the 2 has that exponent of 1. 1 times 3, 3. Same with our next example. G to the 1st, 1 times 2 is 2. H to the 4th, then raised to the 2nd, 8. Okay, so our first question, find a pattern that relates the exponents in the first column and the exponent of the expression in the last column. Okay, so we can say that you multiply the outside exponent to each of the inside exponents. Okay. Now let's look at our algebra example. We have y to the a power raised to the b power. So using our rule, it would be y to the a times b power. And since they're both variables, I'm going to show them next to each other. We could show that dot there. Okay. Number 3, to raise a power to a power, then keep the base and multiply the exponents. Okay. Number 4, Mary says that a to the 2nd times a to the 3rd equals a to the 2nd to the 3rd power. Is she correct? Explain why or why not. Well, let's look at what we actually have here. Let's work the left side first. A squared times a to the 3rd. Well, I know that's a times a times a times a times a. A times itself 5 times. So that would be a to the 5th. Then let's look at the right side. A squared to the 3rd. Well, let's expand that. That's going to be a squared times a squared times a squared, which would be a times a times a times a times a times a. So a to the 6th. So we'd say, no, Mary is not correct. Okay, so no, Mary is not correct because, and we really just proved it, a squared times a to the 3rd equals a to the 5th, and a squared to the 3rd equals a to the 6th, and we know a to the 5th is not equal to a to the 6th. Really, we sort of just did an informal proof there, okay? If you were more comfortable explaining in words, you could have explained in words. We just did it a little symbolically. Number 5, what happens when the exponents are negative? Well, same rules apply. X to the negative 2nd to the 3rd power, that's going to be x to the negative 6, 1 over x to the 6th. No big deal there. Still works. wanted to do just a couple of examples just to show some misconceptions and to sort of drive the point home. So we've got 3a to the third to the second power, one of our power to a power, so remember that's 1 there. Now let's use our rule. So that's going to be, okay, multiply them. 3 to the second, a. 3 times 2 is 6, and then we'll just simplify that. 3 squared is 9, a to the 6. And that works beautifully. Our next example is almost the exact same thing, except this time we have -3, and that -3 still has an exponent of 1. Now, here's where a misconception I find we have, and we have to expose, is that students will take that -3 to the first power, 1 times 2 is 2, and then say, okay, a to the third is a to the 6th, and then simplify. Now remember that -3 squared, no parentheses, means -1 times 3 times 3, which is going to give us -9 a to the 6th. Let's take a second and look at what does this look like if we expand it out. So if we think, okay, base of the 2 is -3a to the third times -3a to the third. Continue to expand that. That's -3 a times a times a times -3 times a times a times a, and we reorder. -3 times -3 times a times a times a times a times a times a gives us +9 a to the 6th. So that, what we did using our rule, that didn't work. And the reason it didn't work was because we had a negative inside of our parentheses there. So we have to make a little adjustment to our rule for power to a power. That when we have a negative inside of our parentheses, if we're going to use that rule, we have to take that negative and put it inside parentheses. So we had -3, I put it inside the parentheses, then raise it to the second power, and then we have a to the third to the second, 3 times 2 is 6. Now this shows -3 times -3, which gives us that +9 a to the 6th. It's a slight little difference. Again, if you're unsure, when in doubt, expand it out, because that worked beautifully for us there. Our final follow-up example is, what do we do when we have that outside exponent of -3? When that outside exponent is negative, we're going to deal with that first. So we're going to take the entire expression here, the whole thing in parentheses, and move it down into the denominator of our fraction. We keep it in parentheses, and then that outside negative exponent just becomes positive. Now we treat the denominator as that regular power to a power. So we have 1 over 3 to the third, a to the 9th, which is going to be 1 over 27a to the 9th. Okay, so now you guys are working on page 12 in your booklet. Feel free to use our rule. Feel free to use a separate sheet of paper and expand it out. Make sure you're checking your work against the answer key so you're getting some feedback of whether you are correct or incorrect. And feel free to reach out with questions. Today's math joke for Matthews folks is a visual one. So what does this image represent? Ray Charles. Get it? To Ray Charles, singer.